Welcome to The Explainer. What if many of the most important concepts in modern mathematics, things like limits, adjoints, you name it, were all just different sides of the same coin? Well, today, we're diving into Saunders Maclean's classic, Categories for the Working Mathematician, to explore exactly that, a single, unifying idea called the can extension.
So Maclean just drops this bombshell right in the preface. It's an absolutely wild claim. He's basically saying that all the big tools and ideas in category theory, they're all just can extensions wearing different hats. I mean, if he's right, it's like he's giving us the secret blueprint for the whole subject. It sounds almost too simple, but that's the idea we're chasing today.
Okay, so to get our heads around that massive claim, we first have to understand the problem that can extensions were even invented to solve. And honestly, it's a problem we all face all the time. How do you fill in the blanks when you only know a piece of the story? Right. Think about it. You've got a really detailed map of your neighborhood, but you need to figure out the layout of the entire city. Or maybe you have a scientific law that works perfectly for a small set of experiments, and now you have to predict what will happen in a much bigger, more complex system. The real question is, how do you do that in a way that's not just a random guess, but is actually the best and most logical way to do it? So in the world of category theory, we formalize this a bit. Our little, well-understood neighborhood is what we call a category, which we'll call M. And we have a set of rules, a map really, called a functor T, that translates everything in our known world M over to some other world A. This functor T is our solid known information. It's what we're starting with. And then, bam, we zoom out. We realize our cozy little neighborhood M is actually just one small part of a massive, sprawling city, C. There are all these new places, new connections, new structures that our original map T knows absolutely nothing about. And that right there, that's the extension problem. How do we draw a new map for the entire city C, but do it in such a way that it still perfectly matches our original, trusted map for the small neighborhood we started in? You can't just make stuff up. You need a principled approach, a system. And this is where the sheer elegance of category theory just blows you away. It doesn't just give you an answer to this problem, it gives you the best possible answer, a universal one. This solution has a name, the right can extension. Now, don't worry about the jargon. It basically gives you two key things, a new extended map, that's the functor R, and a little something that acts like a guarantee, ensuring the new map doesn't mess up anything from the old map. But the word, the most important word on this whole slide, is universal. So what does universal actually mean here? It's not just a fancy word. It means that the can extension is the one true canonical way to do it. It's so perfect that any other solution you could possibly dream up can be understood as just a slight variation of it. In fact, you can draw a unique line from your attempt straight back to the can extension. It's the gold standard. This breaks it down perfectly. The can extension gives you the best path, the ideal solution. Now, say you try to solve the problem some other way, you've just created an alternative path. Well, that property of universality guarantees that there is one and only one way to connect your alternative path back to the best one. It's an incredible organizing principle. All right, so now that we have this incredibly powerful idea of a best possible extension, let's circle all the way back to Maclean's crazy claim from the start that everything in category theory is just a can extension. You know, before this idea really clicked, category theory felt like it had a few different major pillars. You had adjoint functors, which pop up all over the place, and you had limits, which are fundamental for building all sorts of things. They were both seen as super important but totally separate concepts. And here's the big reveal. The core insight of Chapter X in Maclean's book is that those pillars, they aren't separate at all. They're just different shadows being cast by one single, much more fundamental object. And you guessed it, that object is the can extension. And this is what we mean by the grand unification. I mean, look at this list. All of these core bedrock ideas. The famous Yoneda lemma, limits, adjoints. Every single one can be perfectly reframed as the answer to a specific kind of extension problem. They're all can extensions in disguise. And this isn't just some vague philosophical idea. Maclean lays out the proof. For example, taking a limit turns out to be exactly the same thing as asking for the best way to extend your map to the simplest possible category that exists, one with just a single object. The answer to that question is the limit.
It's an incredible, beautiful connection.
Okay, that's really cool, it's elegant, but let's be real. Why should this matter to anyone who isn't a professional mathematician? What's the takeaway here?
Well, the point of digging this deep is that it uncovers a fundamental pattern in how we think. It gives us a language to see the hidden connections in any complex system. And I'm not just talking about math. These ideas are now crucial in computer science for things like database design and even in theoretical physics.
This quote from McLean really gets to the soul of it. He's inviting us to make a mental shift. Stop focusing on what things are, the elements, and start focusing on how they connect and transform, the arrows. A canonical extension is the ultimate example of this. It's an idea defined completely by its universal relationship to everything else.
And that kind of leaves us with one final big question to chew on. This hunt for a single unifying idea, that's not just a math thing. It's what drives science and philosophy forward. So it makes you wonder, what's the con extension in your own field of work or in the problems that you think about? What's the one big idea that makes everything else just click into place?